Okay, let's look at another addition reaction. The hydrogenation. In the hydrogenation, we're going to simply add H2 to our alkenes. So, nice simple alkene, pent-1-ene. And to do a hydrogenation, we take hydrogen gas and we add it in the presence of a catalyst. Typically this is palladium or platinum, maybe nickel on carbon. So carbon, these catalysts, they look like dirt. Because the carbon is typically graphite, and it's graphite coated in palladium or platinum. And you might say, oh, it sounds like it ought to be shiny. It's not enough platinum or palladium or nickel to make the carbon shiny. So it just looks like graphite. And graphite is just a fine black dust. So you mix this fine black dust with your molecule and you pump in hydrogen gas. And what happens is hydrogen adds across your double bond. There's no regiochemistry to talk about here because we're adding the same atom to both sides of the alkene. So we go from our alkene to an alkane, pentane in this case. So let's talk a little bit about stereochemistry in this reaction. Let's use a slightly different alkene. When you do this reaction and you treat it with hydrogen and palladium on carbon, what happens is the two hydrogen atoms both add on the same face of the alkene. Now we're not going to go through the mechanism of this. And by default, when I add things, I'll normally bring them in from the top face. So if the hydrogen comes in from the top face on that carbon, the hydrogen will end up in the up position and methyl group will be down. And on the other carbon, hydrogen's up, methyl is down. And so you can see the two things we added were these hydrogens. Well, the hydrogens end up on the same face. They're cis on the cyclic alkene. They're both up. And therefore, hydrogenation is a syn addition. So hydrogenations are a really simple reaction to perform. And when you do perform them, if there's enough stereochemistry in the molecule to see the outcome, they undergo a syn addition.